In this video, you'll learn how to divide rational expressions. The steps for dividing rational expressions are to factor all the numerators and denominators completely, state any domain restrictions, rewrite your division problem as multiplication by a reciprocal, so we always say keep, change, flip, state any domain restrictions one more time, cancel out common factors, and then multiply your remaining numerators and denominators. So in this first example, we start by factoring the numerator and denominators completely. This first problem is a difference of squares problem, and so I kind of rewrite as a squared minus b squared, so x is a, 2 is b, and then remember the rule is a plus b, a minus b. So that would be x plus 2, x minus 2. The denominator is fully factored, just x. Then on my next numerator, I can factor out a 3x. And remaining, I would have x squared minus 4. In the denominator, it's fully factored. If I look one more time, I notice that x squared minus 4 can be factored further. And so it's actually the exact same as what we factored right here. So I'll come down and rewrite. So I would have x plus 2, x minus 2, all over x, divided by 3x. And then this factors to x plus 2, x minus 2 as well. And then all over 5x to the third. If I state domain restrictions right now, x cannot be 0. Then I want to rewrite my problem as a multiplication, and so we do that by keeping this first fraction alone. So we're not going to change anything. We're going to change this sign to be multiplication. And we're going to flip our second fraction. So 5x to the third will be on top now. 3x times x plus 2 times x minus 2 will be in the denominator now. We have to state our domain restrictions again. So this time x cannot be 0, x cannot be 2, x cannot be negative 2. Then I cancel out my factors, so I have x plus 2 in the numerator and denominator. I have x minus 2 in the numerator and denominator. And if I think about this x to the third, that really means I have x times x times x. And so I can cancel out these two x's with this x to the third, and I would have one x remaining. When I rewrite, I have 5x left, all over 3. In my second example, I'm going to start the same way, so I'm going to factor everything that can be factored first. Here I have a difference of squares problem again, so I want to rewrite it. So I have x squared and then square root of 9 is 3. So I can rewrite this as x squared minus 3 squared. This is my a, this is my b, and remember the rule for difference of squared is a plus b, a minus b. So this would be a plus x plus 3, x minus 3. The denominator would just say x. And then if I start factoring my second fraction, I could factor out a 2x from both terms. I'd be left with x squared minus 9. The denominator, I have 7x to the fourth. If I look again, this can be factored further, And if you notice, it's exactly like my first numerator, so it's a differences squares problem. If I rewrote it, it'd be x squared minus 3 squared. The rule is a plus b, a minus b. So when I rewrite, I'm going to keep my first fraction the exact same. The 2x will stay, but x squared minus 9 is going to be rewritten as x plus 3, x minus 3, all over 7x to the 4th. Then I state any domain restrictions. So currently, x cannot equal 0. And then I'm going to keep. So this will stay x plus 3, x minus 3, all over x. I'm going to change from division to multiplication. And I'm going to flip my last fraction so my denominator becomes the numerator and my numerator becomes the denominator. I state any domain restrictions again, so this time x cannot be 0, x cannot be negative 3, and x cannot be positive 3. Then I can cancel out any factors, so I have x plus 3 in the numerator and denominator. I have x minus 3 in the numerator and denominator. I have x to the 4th in the numerator, and I have 2 x's on the bottom, so if I cancel those out, I just have x squared left on the top. So altogether, I have 7x squared over 2.